Let T1 be the time between a car accident and reporting a claim to the insurance company. T2 is the time between the report of the claim and the payment of the claim. Joint density function of T1 and T2 is constant over the region T1 between 0 to 6, T2 between 0 to 6, and T1 plus T2 is less than 10. Maybe we should push this one, but okay, let's. And 0 otherwise. Calculate E T1 plus T2, the expected time between a car accident and the payment of the claim. So both T1 and T2 are times. We're not told what the individual distributions are, but we don't need that. We just need the joint distribution. And they say joint distribution is constant. So whenever a joint distribution is constant or a region, it's basically the f of T1, T2 is equal to 1 divided by area of the region, or the reciprocal of the area. So just like uniform distribution is the reciprocal of the interval length. And the thing about uniform distribution is that it's constant. And similarly, if we have a constant distribution in two variables, it's the reciprocal of the area of the region. So the total area of the region is here. We had T1 plus T2 is less than 10. So the diagonal line is the T1 plus T2 equals to 10. So less than 10 will be all the region below it. So basically the whole triangle. But we're also given the T1 is between 0 to 6 and T2 between 0 to 6. So 0 to 6 for T2 and 0 to 6 for T1 cuts it off, and we actually have this yellow region. That's the total region under consideration. And we need E of T1 plus T2, so that's always equal to E of T1 plus E of T2. In general, E of x plus y equals EX plus EY. So the region is symmetric in the two variables, we can see. And the joint PDF is constant. So basically E of T1 will be the same as E of T2. So the area of the shaded region is the sum of areas of the rectangle and a trapezoid. So you see this total area can be split up into this rectangle on the left and this trapezoid on the right. Okay, so we have for the rectangle, the base is 4 and the height is 6, so it's 4 times 6. And for the trapezoid, it's half times base and then h1 plus h2, and base for the trapezoid is 2 because the x value here is 4 and the x value here is 6. So half times the base and then h1 plus h2. So this height is 6 and this height is 4. And so the total area comes out to be 34. Therefore, the joint PDF will be 1 by 34. And as we discussed, we just need E of T1 because E of T2 is the same. So E of T1 in general will be all the double integral of T1 against the joint distribution, dt2, dt1. And negative infinity to infinity is on the T1. So the outer limits are on the T1 and the inner limits are on T2. So now what we see is that as long as we are in this rectangle part, the T2 is between 0 and 6, and T1 is between 0 and 4. So that's what we have. So T1 between 0 and 4, and T2 between 0 and 6. And then the f of T1, T2 is 1 by 34. And the T1 stays as it is. But once you are in the trapezoid part, the T2 is from 0 up to this part, and the t2 on this part is 10 minus t1. So t2 is from 0 to 10 minus t1. Yeah, that's what we have. T2 from 0 to 10 minus t1. And the t1 in this part is from here to here, and that's 4 to 6. Okay. So after we've set these up, then it's routine thing. So this first integral is with respect to t2. So the 1 over 34 times t1 is constant, and the integral of dt2 is just t2. And t2 goes from 0 to 6. And then in this part, it's again 1 over 34 t1 is just constant, and the integral of dt2 is just t2 from 0 to 10 minus t1. And so after you substitute the limits, you get this, and then it's just one variable integration. The 6t1 integrates to 6t1 squared by 2, so that's 3t1 squared, and similarly this one. And after all said and done, ET1 comes out to be 2.86. ET1 plus T2 is what we need, so that's ET1 plus ET2, and we said by symmetry that ET2 will also be the same as ET1, so 2.86 plus 2.86 is 5.7, which is choice C.